And all right. Is this a polynomial? Yes. We do not have any variables in the denominator. We don't have a power that's a variable. All the powers are numbers. So it is a polynomial. What is the degree of it? 6. What's the leading coefficient? 2. It's not always the first coefficient. It's the coefficient of the highest power is the leading coefficient. Okay? Now, this one you can just graph on your graphing calculator and match up which one works. But our vertex should be the opposite of this, same as this. So 1, -5. And because it's a 3, it opens up and it's skinnier. Okay? So if we go 1, -5, opening up, I think B could be the only one that it is. Okay? The correct graph is the only graph that places a vertex at 1, -5, and it opens upward and passes the points 0 something and 2 something. So to figure out where it passes through on this one, to figure out 0 whatever, you have to figure out the if the x value is 0, we plug it in. Okay? So if we plug in a 0, 0 minus 1 is -1. -1 squared is 1. Times 3 is 3. Minus 5 is -2. Okay? So 0, -2. And because this is 1 to the right or 1 to the left of the vertex, you go 1 to the right of the vertex, everything's symmetrical. That will also be a -2. They match. Okay? You could also push trace on your graphing calculator. If you put this equation in your graphing calculator, you push trace and you push 0, it'll tell you where you're at. You're going to be at a -2. Okay. This one, again, you can graph it on your graphing calculator. Now, the tricky part of this is completing the square. So you go x squared minus 4x plus blank plus 5 minus blank. Whatever you add to here, you have to subtract from here. So to figure out for completing the square, you take half of this, which is -2, and you square it, which is 4. So 4 goes there and there. So this becomes the square root of this, which is a negative sign, and then 2, quantity squared. X minus 2 quantity squared will give us x squared minus 4x plus 4. This divided by 2 helps us find this number right there. Okay? And then in the end, -5 minus 4 is plus 1. So you match that up, and this is the one it matches with. X minus 2 quantity squared plus 4. The reason why it's a minus is because that sign's a minus. All right, so the graph is an upward opening because this is positive parabola with a vertex at the opposite of this, same as this, so 2, 1. The axis of symmetry is x equals the x value of the vertex, x equals 2. The intercepts, well, if it's at 2, 1, and it opens up, its y-intercept is up here at 5. If it opens up, is it going to have any x-intercepts? The answer is no. It does not have any x-intercepts because it starts above the x-axis and it opens up. Okay, so it's upward opening, and the axis of symmetry is x equals 2. All right, this is a power function. It's 1/2 x to the 1/4 power. Because it's the fourth root, it's a 1/4 power. The constant of variation is 1/2. It looks probably like this one. The domain starts at 0 and the range starts at 0. It goes forever up and forever to the right. And it doesn't mirror around the x-axis or y-axis, so it is neither. Okay, a graph transformation. Compared to x cubed, we have this graph. Okay. The plus 3 means it goes 3 units to the left, and the 2 is the multiplier, so it is stretched vertically by a factor of 2. So we go 3 to the left, 1, 2, 3 to the left from the normal x squared. Okay. And normally we'd go over 1 up 1, but since it has a multiplier of 2, we go over 1 up 2. So it's going to look like this. Now, it wants the y-intercept. To find the y-intercept, I have to multiply all this out, or else put it on my graphing calculator and trace to 0. 0 whatever. It works out to be like 54, I think, the y-intercept. Because 3 cubed is 27 times 2 is 54. So I think that's what it works out to be. All right. Okay. Oops. We did a little bit of this on today's assignment. It crosses at 2, it crosses at -3, it crosses at -4. Crosses at 2, -3, and -4. So it looks like this one right here. You have to zoom in to see. So as it's going to the right forever, it's going up forever. As it's going to the left forever, it's going down forever. So it would be this one right here. As it's going infinity to the right, it goes up towards infinity. As it goes infinity to the left, it goes down towards negative infinity. Okay? The zeros of this function, we can factor this. Take out an x first, and we get x squared minus 2x minus 8, x minus 4, x plus 2. The zeros are 0, 4, and -2. Synthetic division, the nice thing that we have is we have the answers. It's multiple choice. So -4, 3, 16, 14, -13. -4 times 3 is -12. Add to get 4. You get -16. Add to get -2. You get a +8. Add to get -5. So it's 3 at r squared, because if this is r cubed, we drop a power every time we go down. 3r squared, 4r minus 2 plus this is over the denominator. So it would be this one right here. The remainder theorem is, what do we get for a remainder when we do synthetic division? Now, if they give us a number, it's that number. If they give us an expression, use the opposite of the number. Know when to use the number, know when to use the opposite. 3, -11, 6. 3, 6, -5, -10, -4. The remainder is -4. Is this a factor? To figure out if it's a factor or not, we need the remainder to be what number? 0. If the remainder is 0, it's a factor. 1, -5, 2, -10, -8, 40, 0. Yes, it's a factor. Okay, potential zeros. You take all the factors of the last number, 1, 5, 7, 35, over all the factors of the first leading coefficient, 1, and it's a positive or negative of that. So it's this one. And to find the zeros, again, thank God it's multiple choice. You know this isn't the answer. There's more than one answer, so this isn't the answer. But you got to figure, oh, if they put a 1 down there, that's probably going to be an answer. So we're going to try 1 first. 1, 11, 23, negative 35. 1, 1, 12, 12, 35, negative 35, 0. Okay, we found one of the answers. So I bet negative 5 is another answer. 1, negative 5, 7, negative 35, 0. So you know it's this one. Oop, you know it's not that one. You know that it is this one. 1, negative 5, 7, negative 7. Now, this is the one that might take you a little bit of time to do. The next couple here. Okay? X minus 5 times x minus 5. Okay? Identify the zeros. Oh, simplify your answer and then identify the zeros. So, x minus 5 times x minus 5. If we FOIL this, we get x squared minus 10x plus 25. This part, when we do this, the sum of 6i and negative 6i is 0. Their product is negative 36i squared or plus 36. So it's x squared plus 36 is what we get for there. And then we have to FOIL this to get x to the fourth plus minus 10x cubed plus 25x squared plus 36x squared minus 360x plus 36 times 25, 900. So it's x to the fourth minus 10x cubed plus 61x squared minus 360x plus 900. So the zeros of the function are 5, negative 6i, and 6i. The x-intercept is just 5 because the zeros are the x-intercepts. We're supposed to write a polynomial where 2 is a multiplicity of 2. So it's x minus 2 times x minus 2. And then 5 plus I is a root. So that means 5 minus I is also a root. So if we find the sum of these two, it's going to be 10. Their product, if we FOIL 5 plus I times 5 minus I, we get 25 plus 5i minus 5i cancels, minus I squared, or 25 minus a negative 1, or 26. So our other function is x squared minus 10x plus 26. It's x squared minus the sum of the roots times x plus the product of the roots. And I can put that formula on the board if we need it for tomorrow. So if we FOIL this, it's x squared minus 4x plus 4. And we multiply all this out. So it's x to the fourth minus 10x to the third plus 26x squared. Done with that one. Negative 4x times x, negative 4x times x squared is negative 4x cubed plus 40x squared minus 104x. And 4 times everything is 4x squared minus 40x plus 104. So it's x to the fourth minus 14x cubed plus 70x squared minus 144x plus 104. Okay, if 6i is a 0, what's another 0 that I absolutely know? Negative 6i. Okay. So then I know those two zeros. So if I do the sum and product of the roots there, the sum of these two is 0. The product is negative 36i squared or plus 36. So if it's x squared plus 36 is the root, then I can use long division. To find out what the other ones are. What times x squared is x to the fourth? X squared. So I get x to the fourth plus 0x cubed minus plus 36x squared. Change the signs on the bottom row and then add, and we get negative 11x squared. And I drop the other two down. And then minus 11 is negative 11x squared plus 0x minus 396. Change the signs on the bottom row, and then we add, we get 0. So x squared minus 11 equals 0. X squared equals 11. If we take the square root of both sides, x equals positive or negative square root of 11. That's the other two roots. The linear factorization of this is x minus 6i, x plus 6i, x minus the square root of 11, x plus square root of 11. Okay, the domain. What can x not be? Negative 3. So the domain is all real numbers except for negative 3. Now, when we look at the graph and you graph it on your graphing calculator, it looks like that. So as we go, whoops. Here, let me redo that. So at negative 3, there's an asymptote, so it looks like that. As we go towards negative 3 from the left, it goes towards negative infinity. As we go from the right, it goes towards infinity. For this one, we factor the denominator, x minus 6, x plus 4. So, find the horizontal asymptote. You look at the powers of the highest terms of the numerator and denominator. If the denominator is higher than the numerator, the horizontal asymptote is y equals 0. Horizontal asymptote is 0, which is the x-axis. If they're the same power, then you use the coefficients of the two powers. If the power on the top is higher, then it doesn't have a horizontal asymptote. The vertical asymptotes are what you get when you set your denominator equals 0. So it has two vertical asymptotes. At the left one is x equals negative 4, and the right one is x equals 6. You solve both of those. To find the x-intercepts, you set your numerator equals 0, x equals 1. And to find your y-intercept, you just graph it on your graphing calculator and figure out where it happens. And it happens at 0, 1, 24th. Because you just put a 0 in for all the x's, and you get negative 1 over negative 24, which is 1 24th. So asymptotes at negative 4 and negative 6, or positive 6, negative 4, positive 6. And you just got to look at the graph. I think it would be this one, but I'm not sure. That's why graphing calculators help us out here. And then we did this fairly recently. Multiplied this by x minus 3, this by x minus 3, and this by x minus 3. So we get x squared minus 3x plus, these cancel, 7x. These cancel, equals 21. So x squared plus 4x minus 21 equals 0. factor x plus 7, x minus 3 equals 0. So x equals negative 7 and x equals positive 3. You try 3 in here, the denominator is 0, so that doesn't work. So the solution is negative 7. X plus 2, x minus 6 is how this factors. So we multiply every numerator by that. So if we multiply them all by that, it's 6 times x plus 2. It's 3 times x minus 6, and it's 8x. So 6x plus 12 plus 3x minus 18 equals 8x. 9x minus 6 equals 8x. Move them over, x equals 6. If x is 6, then that doesn't work. So there is no solution. Then this was today's. Negative 4, negative 1, and 8. It crosses at negative 4, negative 1, and 8. It says where is it positive? In between negative 4 and negative 1 and past 8. Where is it negative? Less than negative 4 and in between negative 1 and 8. And then if we factor this one, x plus 1, x minus 1, x minus 8. So the graph, we cross at 8, 1, and negative 1. Where is it less than 0? From negative infinity to negative 1, and from 1 to 8. Those are the 20 questions. Now, I know tomorrow is 45-minute classes. If you don't get done with the test tomorrow, it's not the end of the world. You'll just stop it, and then you'll just do it Monday morning. Monday morning study hall. Now, I know there's band and choir. Well, actually, they're just choir, but we'll find a time to do it, maybe after school Monday, okay, if you're in band and choir, if you don't get it done tomorrow, okay? So, be ready for this. Take this practice test a couple times. You still have 20 minutes, 25 minutes almost to work on this. So, work on this. Practice. Do the problems that you don't understand. Make sure you get those down. Make sure your graphing calculators are charged for tomorrow.